Welcome, and thank you everyone for joining us here today. It's really great to be back together again. In fact, it's also been a great year. And that year is only because of what this community has done together. So I wanted to just take a few minutes to underscore just a few statistics that highlight the amazing energy that's come from this group. So let's start with one that is truly led by all of you, which is the HashiCorp user groups, the hugs as we call them. Obviously, as we were going through the pandemic, we couldn't get together and it was very challenging to meet in person, which is why it is so satisfying for us to see that our hug community grew by 17% year over year. If you haven't had the opportunity to participate with some of our local leaders, either learning new technical things or just meeting new people in your community that have similar interests and similar career paths as you do, I highly encourage you to do so. As you can see, there are literally user groups all over the world, including across all the major cities in Europe. But it's not just about community engagement. A lot of those hugs are the basis for how people transition to getting certified as HashiCorp certified engineers. We had a really cool milestone of actually reaching over 1,000 new engineers certified every single month this year. Those certifications, either as a Terraform certified engineer or a Vault certification or a Consul certification, they tell the world that you are ready to be a significant part of our customers' collective cloud futures. And obviously this investment in deeply understanding the tech extends to our partners because we integrate with other things. And so we today work with over 900 companies from across the globe, which is a mind-numbing number. In fact, key partners and members of our community have created more than 3,000 integrations across our products. The most significant, obviously, is Terraform, where there are almost 3,000 Terraform providers alone. And if you haven't had a chance to look at registry.terraform.io, you'd be shocked at just how fast that community is growing. Literally anything you want to include as part of your automated infrastructure, you can be comfortable that an integration already exists. But we've also been working with hundreds of your system integrator partners to build out the skills to support the transformation initiatives that we are all a part of. And that's not just about the technical know-how, it's also about the changes required in people and processes inside of companies to make this happen. As you can see, our partners align to various areas of competency. If you want to focus on provisioning, we have Terraform certified partners. If you want to focus on security around Vault and Boundary, we have partners with that competency. So regardless of which aspect of the cloud transition you're working on, just know that we have partners in our ecosystem who are ready to support you. Ultimately, what we do is in service of the companies that we serve. And so it is incredibly satisfying and a privilege for us to know that our products serve at the heart of some of the most important companies in the world's cloud transitions, just a few of which are on the screen here behind you today. This is why we do what we do, is to serve what these companies are trying to achieve in cloud. As part of that commitment to continually improving experiences, I'm very pleased to share that our cloud offerings averaged 3,000 new weekly signups this year. That's an amazing statistic and commentary on the collective work that we are doing within the community, because we don't build these products alone. Many of you in the room are contributing plugins and providers and pull requests into our core products, and that allows us to do what we do. And the fact that we have 3,000 people in our cloud offerings just speaks to the level of interest and demand for what you have created. So it's very clear that there's an infrastructure transition underway, and I'm super excited to be a part of it with all of you. But we also know this is happening against the backdrop of a challenging macro. High inflation and resulting high interest rates. All of that's putting a lot of pressure on our customers to make every investment count. And as I visit with customers around the world, I hear very consistent messages about how cloud is helping them, how it's helping them to respond more quickly to opportunities, how it's helping them to modernize their infrastructure, and how it's allowing them to do all of those things more efficiently and more securely than without cloud. That feedback is very consistent, but today I'm also excited to share that it's also quantifiable. As part of the conference today, we're unveiling the 2023 State of Cloud Strategy. It's available on our website, so you should go check it out if you can. But I wanted to share a few important findings with all of you. The first is that the continued investment in cloud computing, keeps on going. More than 56% of respondents saying that they increased their cloud spending last year. This is despite the macro challenges I just mentioned. So the foundational commitment to increasing investment in cloud computing remains strong. The second important finding is that multi-cloud is the clear winner when it comes to how organizations are placing their bets on cloud. This shouldn't be surprising to any of us. Over 3/4 of respondents are actively engaged in a multi-cloud strategy, and 92% of them say it's delivering the business results that they expected. The third finding is that in this push for multi-cloud adoption, the biggest limiting factor is the ability to find and retain talent. It's skills. The skills gap is real, and it's something that we're actively working on every single day by making our products easier to consume. But we're also working on it through our huge community of partners that help our customers implement the technologies that we build and to manage those technologies at scale. An important new set of questions that we asked this year that we did not ask prior focused on the maturity of companies' approach to cloud computing. Because we think maturity is a core concept that makes this repeatable for all of us. And the results show that really no matter the question, from getting business results, to the ability to attract and retain talent, to the use of platform teams, those with a more mature cloud technology and organizational practice, and that organizational practice is key, saw better results than those with lower maturity. There are a lot more findings in the full report, so please do check it out for yourself. As I said, it's available online today. Now, in practice, the path that we see organizations take to adopt cloud is in fact incredibly consistent. There are multiple phases to it. In fact, we describe them as 3. In that first phase, all things are very ad hoc. You sign an enterprise agreement with Amazon or with Azure or GCP or your cloud partner of choice. I set my devs loose and I say, go build something because you need to, and off they go. You know, invariably 6 months later, you're way overspent on your cloud bill, your security teams are freaked out by what's happening, and actually that journey to cloud grinds to a halt. Apps 3, 4, 5, and 6 never get there. What we see in companies that are successfully adopting cloud is a slightly different model. We call this phase 2 of cloud. It is at this phase where the realization emerges that I need to standardize how I'm doing 3 core things: how I provision compute, how I think about security, and how I think about networking. You can build whatever apps you want on top, but you have to be doing those 3 things in the same way. Practically speaking, this means the creation of a platform engineering function, or a cloud program office, or a cloud center of excellence, people call it different things, wherein I am going to run a central shared service of Terraform, and no matter which cloud you're deploying to, you need to consume that from that shared service. This way I can apply policy and governance and audit trails over who did what. I run a central shared service of Vault, and everybody has to consume that when they deploy their applications. It is this stage 2 of cloud which unlocks the organizational construct that's required for apps 3, 4, 5, 6, 7, and 8 to go cloud, which is ultimately what we're all trying to accomplish together. There's actually a third stage of cloud, which we call stage 3, and that's when you start applying this to your private data center. Because it turns out it takes me 30 seconds to provision 100,000 machines on Amazon, but it takes me 3 weeks to provision a virtual machine on vSphere. Why? Surely I can just use Terraform to provision the virtual machines, and of course you can. So as organizations mature, they then adopt this cloud model in the private data center as well, and unlock enormous scales of efficiency through automation that were not previously possible without the cloud native approach. We've also learned that this maturity journey follows a relatively predictable progression through our product portfolio. It starts with the provisioning challenge, which is addressed by Terraform, and then organizations address the security challenge, then they realize the networking challenge, and so we go. So people think about the problem domain in layers as they progress down a maturity path, but fundamentally it starts layer by layer by layer. So let's hear directly from Deutsche Bank on how they've been able to do more with their HashiCorp cloud operating model based on Terraform.
Thanks, Dave. So my name is Keith Kemsley, and I'm the head of cloud automation and delivery at Deutsche Bank. I am here to share our journey towards cloud maturity, the challenges we faced, and the significant progress we've made. 3 years ago, we embarked on a cloud transition journey with Google GCP as our primary cloud provider. As we stand today, we have successfully migrated the applications, including our core online banking solution that serves millions of retail customers. While the benefits of the cloud were evident, the transition wasn't without its challenges. Data sovereignty, security, and regular compliance were areas that required meticulous attention. To address these challenges, we built a dedicated, specialized organization that focused solely on the cloud transition, embracing a shift-left approach to ensure early detection and resolution of issues. This approach, while challenging in some quarters, proved vital in maintaining the progress of our transition. A significant aspect of our transition was the planning and design phase. We created a meticulous plan and stuck to it unwaveringly. We adopted a dual strategy of rehosting and creating native applications, focusing from the start on security and operational simplification. Simultaneously, we challenged legacy processes to drive efficiency and modernization across our bank. Our platform teams played an integral part in this process. They worked tirelessly to ensure our applications were ready for the cloud and helped reshape our infrastructure. We adopted a strategy based on R types: rehost, re-architect, re-platform, and retain. This approach allowed us to place applications into the correct environment and build the most optimal operating model for each. Our journey towards cloud maturity, although challenging, has been special. We did not merely transplant our existing operations to the cloud. Instead, we built everything from the ground up, with an unwavering focus on leveraging the strengths of cloud technologies. For our partnership with HashiCorp, we made a decision to adopt Terraform Enterprise. With the inclusion of Sentinel, it allowed us to construct the necessary guardrails for safe infrastructure delivery, increasing velocity and adoption. As a result, our ability to respond to market opportunities has greatly improved thanks to increased developer productivity. We have significantly reduced security risks. Lastly, we've managed to enhance operational efficiency, leading to considerable cost savings. Looking to the future, we remain excited about what lies ahead. Our journey continues as we aim to realize the full potential of this cloud-first strategy. It's our goal to serve our customers better and build a more resilient and innovative financial services industry. Back to you, Dave.
Thank you to the team from Deutsche Bank. It's always super cool to see what people are doing with our products, and we are hugely, hugely privileged to play that role, so thank you. To wrap it up, I want to bring it back to this view, which I think is actually a very good framework for how we think about our portfolio, matching the maturity evolution of our customers to their cloud journey progression themselves. This really is a good framework for me to hand it over to Armon to take us through some of the product updates that we are announcing here at the event. So from here, Armon, over to you.
Thanks so much, Dave. I'm super excited to be here for HashiDays, and we have lots of great product updates for you, so super excited to be able to share all of that. As Dave said, using this sort of framing, I think is an interesting way for us to talk about the maturity journey that we see many of our customers and users go on as they think about their cloud programs. And I think it's not a surprise that the foundational layer here really starts with infrastructure as code. We firmly believe that that is the foundational layer in terms of moving to a model where we have an as-code declaration of what intent is, and that starts to let us apply all the great benefits of version control and automation. But more than that, it starts to layer on and enable these next layers, such as identity-based security. We can drive policies based on the identities of applications and the identities of human users. It lets us move up to network automation, where we think about that life cycle of not only the applications, but how it might impact the networking that supports those apps. And then all the way up to the highest level, which is the application delivery with tools like Nomad and Waypoint. Obviously, this is a very broad portfolio, so we're not going to be able to talk about the entire portfolio today. So we're really going to focus in on 4 layers of this solution, right? So going to be sort of security focused at the core of this, but we're also going to touch on Terraform. Obviously, there's lots of other updates that we have across the whole portfolio, so you'll hear more about us, whether it's online at other sessions throughout the conference or at this fall at HashiConf. So with that, I want to jump right into Vault. And when we talk about Vault, at the core, it's really about an identity-based approach to secrets management. And so what does that really entail? Obviously, there's multiple aspects to this. At the core, when we talk about secrets management, not a surprise, we're talking about secrets. So this might be usernames and passwords, might be API keys, might be certificates, basically any type of a credential that we'd like to keep sensitive and secure that enables us to access or authenticate against another system. So most people think about Vault primarily around secrets, but just as much it's used for certificate management automation, encryption keys, as well as data protection, whether it's data in transit or data at rest. Now, oftentimes when we talk about Vault being used in production environments, one of the most common platforms that it's used with is Kubernetes. And there's a very strong Vault and Kubernetes story. Obviously, we've had things like Helm installers, so you can easily deploy Vault into a Kubernetes environment and operate it. We have a Kubernetes secret engine, which allows you to dynamically generate and rotate access keys for Kubernetes. And we have multiple ways for applications running within Kubernetes to authenticate as a workload to fetch secrets out of Vault. That said, I think one of the complaints or challenges that we've seen is oftentimes that integration requires having to run a sidecar with each of your pods. So in each of these Kubernetes environments, we had to have some level of configuration to put that sidecar in, whether that was using the Vault agent or a different tool, so that that pod and the application could fetch a credential out of Vault to do a secure introduction of those credentials. Obviously, this works fine, but it involves a little bit more toil for our Kubernetes developers to have to do that configuration properly. So something I'm super excited to talk about today is the general availability of the Vault Secrets operator for Kubernetes. And what this really does is it takes a tool that we've brought to beta about 3 or 4 months ago. It's been wildly popular. We've been getting a lot of great feedback in terms of it simplifying the Kubernetes experience. And now we're taking that tool and making it generally available. So what does this actually change? Well, if we look at that picture from before, what we had was a sidecar running in every single pod. What the new approach lets us do is run a single operator. That operator then interfaces with Vault, fetches the set of credentials that our applications needs, and syncs that into the Kubernetes secret objects. So what that enables is now the pods don't need to have a separate sidecar. They can use the native mechanisms to access the secret. That secret behind the scenes is being populated and kept in sync with Vault. So this simplifies the workflow tremendously, especially if you're just getting started and you're using static credentials, makes it way simpler. So now this Vault Kubernetes operator is generally available. You can get started with it. In the same vein, right, I think the reason we created tools like the Kubernetes secret operator is to make it easier to access Vault. And this has been a continuous theme for us from the very beginning. When we started with Vault, obviously it was an open source project that you had to download, you had to run it, you had to sort of self-manage it. And I think that worked in terms of getting really quick to market. It was easy to download and get started. It was a single command to run Vault dev environment. But obviously it comes with challenges in that you have to now operate it, you have to do backups, you have to do version upgrades. So over time, the Vault offerings have evolved. We then introduced the Vault Enterprise offering. That obviously brought more feature set and enabled large enterprises to really solve their set of challenges with Vault. But it was still operationally similar to the open source model. You had to download it, you had to operate it, you had to think about life cycle. So to solve those challenges, we then introduced HCP Vault. This is our fully managed offering of Vault. It's a part of the HashiCorp Cloud Platform, or HCP. And what this really enabled was a push button deployment. Now you could click a button and within a few minutes have a cluster that's managed and delivered for you, where it's HashiCorp's responsibility to do version upgrades, backups, all of the fun stuff in terms of operating a high-scale service. And so we've continuously invested on how do we continue to make Vault easier to operate, more accessible, and lower that barrier to entry. So in that vein, I'm super excited for the next step on this journey, which is the introduction of HCP Vault Secrets. HCP Vault Secrets takes what we've done with HCP Vault, now known as HCP Vault Dedicated, and makes it even simpler. Now you don't have to think about getting started and right-sizing a cluster, or thinking about versions of Vault. Instead, you can instantly come in and start onboarding into Vault Secrets and start storing and retrieving secrets without managing clusters, without having to manage and think about infrastructure, right? Really much more of a serverless type of experience. And so without taking too much away, from here I'd like to hand it over to Val, who's going to do a walkthrough and demo of HCP Vault Secrets. And so with that, I'll hand it over to you, Val.
Thanks for the intro, Armand. Hi, I'm Val Conklin, an engineer on the HCP Vault Secrets team. Let's take a look at our new cloud-native security product. Let's say I'm a developer working on building a Slack bot to post helpful messages to my team's Slack channel. As you can see, I've done something pretty dangerous here. I've got the token that lets my app authenticate to Slack just sitting here hard-coded for the world to see. That's no good. At least for my local dev setup, I'd like to have these values read from environment variables. Here you can see I've logged into my account on the HCP dashboard. You'll notice there's now a new Vault Secrets tab. If we click on it, it'll bring us to the HCP Vault Secrets overview page. Here, I can create a new application to logically group my secrets in. Let's call our app Slackbot. Now we can create some secrets for our Slackbot application. I can give our secret a name that matches how I'll be referencing it in our application, and I can give it our Slack token as a value. Let's go ahead and add our Slack channel as a secret as well. It's all pretty simple. We didn't even have to configure a Vault cluster. Now let's switch over to the terminal to see how we can actually get these secrets into our app. After installing the Vault Secrets CLI and authenticating with the Vault login command, we can then use the secrets command to see the list of secrets that we added to our application in the UI a moment ago. Now let's get those secrets into our app. It's as simple as running vault run with the command flag set to whatever command we typically use to run our application locally. This will invoke a new process with all of our app's secrets injected directly from HCP Vault Secrets. Awesome. Looks like our Slack bot is working as expected without any hard-coded secret values. Now here's something really cool. As most of you know, in production we often have resources in a variety of places that need access to secrets. Things like CI/CD flows in GitHub Actions, multi-cloud deployments, and so on. With HCP Vault Secrets, we can now have a single source of truth for all our secrets, and then sync those secret values to a variety of destinations. For our example, imagine we have our Slack bot running in AWS, retrieving its Slack token and Slack channel from AWS Secrets Manager. I've got some Terraform here that provisions our production infrastructure, including an IAM role that HCP Vault Secrets will assume when syncing secrets to your AWS account. Let's take a look at how the AWS Secrets Manager integration works. All you have to do is go over here to Integrations and choose a sync destination. Enter some details, including the role that HCP Vault Secrets will be assuming to manage secrets in your AWS account. I'll grab that role's ARN from our Terraform output. Now we've installed the integration, and we can see that our Slack token secret will get synced over to AWS Secrets Manager and automatically updated whenever we update our token value. As we continue to add more secret sync destinations and even automated rotation options, you can see how this will make it easy to manage the secrets of a complex multi-cloud project all in one place. We're super excited to have you give the new HCP Vault Secrets a try. Thanks. Back to you, Armon.
Awesome. Thank you so much, Val. Super exciting demo. It's really exciting to see how easy it is to get started with HashiCorp Vault Secrets. I think the secret syncing capability is super powerful as well. Makes it easier to have all of your secrets located in one place and to be able to sync them across any number of different systems, which will continue to expand over time. So with that, I want to take a moment and just summarize the Vault announcements. Obviously, we just saw a demo of the HCP Vault Secrets service. This is available today, so get started with it. You can go to HCP and sign up for free and start playing around with that right away, as well as the Vault Secrets operator for Kubernetes. As I mentioned, that's now generally available as well, so feel free to get started with that, and we're looking forward to getting feedback on both of these. Next, I want to switch gears to talking about Boundary. And when we talk about Boundary, it's really about identity-based user access. And this is in contrast to Vault, which is really about identity-based machine access. So think about Vault as really in that machine-to-machine use case. A web application needs database credential, interacts with Vault, versus Boundary is more about human users. So I might be a developer, or I'm a DBA, and I need access to a production database. How do I get access to that? So when we think about the challenge Boundary is solving, it's really threefold. First is how do I authenticate using my existing form of human identity? Two is how do I connect to these systems based on a logical set of authorizations, right? I don't want to manage specific IPs and hosts. And third is how do I do this securely where I'm not giving my users access to my whole network when they really only need access to a specific set of services. So what does that actually look like? Well, it starts with the user and what they want to connect to. And first, they authenticate against Boundary using some form of identity. That might be, Azure AD, might be Okta, might be Ping, might be some other identity provider. But again, we don't want a separate username and password or credential or certificate. Next is we're going to define those logical authorizations of what the user can connect to based on services, right? So this might be a service identity sourced from Kubernetes, from Consul, from the cloud providers directly. But this lets us move away from having to manage a set of static IPs, particularly in a cloud environment where they're changing all the time. Then based on that, we can ask Vault to initiate a connection to the target instance, right? That target instance might be a database, and Vault is generating a dynamic credential for that database. It might be a SSH environment, and we're using Vault to get a dynamic credential for that SSH environment. And so then that credential is used to automatically connect to the target instance on behalf of the user. And so at that point, the user has an end-to-end connection between their desktop environment and the endpoint machine that they want to connect to. Ideally, they never saw the underlying credential that was sourced from Vault automatically. And more importantly, they never had access to the network because Boundary is acting directly as a reverse proxy on behalf of the user. So now, taking a step back, I think what we've heard from users and early adopters of Boundary is that it solves a very important problem for them. It makes it simple for them to move to a zero-trust model. It allows them to eliminate VPNs and SSH bastions, and it really moves to a more secure, need-to-know access basis for these environments. However, what we've heard from our largest enterprise customers is that HCP Boundary isn't always a fit for them. Because it's cloud-hosted, it might not solve for some of their different requirements around data sovereignty, about needing to be offline. Maybe they want to be able to self-manage it for various reasons, like data privacy concerns. And so for these very large enterprises, we're super excited to announce today the introduction of Boundary Enterprise. And so with Boundary Enterprise, what this enables our customers to now do is to self-manage the entirety of the Boundary experience. And so what does this enable is if we think about all of the moving pieces in a Boundary deployment, there's really three important components. There's the Boundary client that always runs on the endpoint, the user's laptop or workstation. There's the Boundary controllers, which you can think about as the brains of the system. And so in an HCP Boundary environment, that's delivered and managed by HashiCorp versus in Boundary Enterprise, that's self-managed in your own environment, whether that's cloud or in a private data center. And then you have the Boundary workers, right? And you can think about these as the gateways that allow traffic to flow. So in a standard deployment, the Boundary client would authenticate against the controller. That's where it would establish a session. The controllers would interface with tools like Vault, for example, to be able to generate dynamic credentials, as well as store data in a backend Postgres database. And then once the session is authenticated and established, the traffic flows directly between the client and the gateways. And there might be multiple gateways. So if we take the example of a secure PCI network, the client might first connect to the private data center network. Then from the private data center network, there might be a hop onto the PCI network. And from the PCI network, the client might connect directly to the target instance that it's connecting to. So there might be multiple hops along the way. Now the entirety of the solution is possible to run in a self-managed mode with Boundary Enterprise. Now, beyond just establishing these sessions, what we also want to know is what are the users actually doing? And this might not be applicable in all situations, but certainly if we think about things like SSH, and we're a highly regulated organization and we take security very seriously, we want to know when a user's logged in, what commands did they run? Did they exfiltrate data that they shouldn't have? Did they run commands they shouldn't have? Did they install packages that probably shouldn't be installed? And so today, a user might establish a session and Boundary will securely connect them to that. But then what happens within that session, we don't necessarily know without additional layers of tooling or additional layers that we build around Boundary. So I'm very excited to announce today the introduction of session recording for Boundary as well. What this really enables is now being able to enable selectively for different targets the ability to record what the user actually did within a particular session. Today we're introducing this particularly for SSH, but we'll expand this capability to other types of sessions as well. And so to give us a deep dive of what this actually looks like, I'm going to hand it over to Adam. Adam, over to you.
Thanks for the intro, Armon. Hi, my name is Adam Boumad, and I'm a product manager on the Boundary team. Since the launch of Boundary in 2020, session recording has been the most requested feature. Boundary SSH session recording will allow administrators to get insight into user actions over remote SSH sessions. Administrators will be able to enable session recording on SSH targets in their Boundary environment, have signed recordings be stored in a storage bucket, and have the ability to play those recordings back within the Boundary admin UI. In this demo, I'm a security engineer at a Fortune 500 company. Due to a compliance mandate, we're needing to set up a system of record to archive actions taken within our environment. We'll go through the setup of session recording on a target and review actions a malicious insider has taken on a machine. I already have multiple workers set up, which will proxy and record our SSH traffic for us. Here, we have a storage bucket configured using AWS S3 as its backend. This is where our session recordings will be stored. You can see I'm going into one of my boundary scopes and already have an endpoint configured as a target. For credential management, we're using our integration with HCP Vault to create and inject SSH certificates on behalf of our users that connect to this machine. This will enable users to have a passwordless experience. For auditing purposes, I'll enable session recording on this machine. Once it's enabled, any sessions established to this target from any user will be monitored and recorded. I've also specified the storage bucket I want to use to store this target's recorded sessions. Now, we'll have one of our users, John, connect to this target using Boundary. John can use the Boundary desktop client or the CLI. In this case, he'll authenticate to Boundary using Auth0 and use the Boundary SSH helper command to connect to the target. A Boundary worker will proxy his authorized session to the machine, and from there, it looks like he's running some pretty interesting commands. Once a session is complete, I'll switch back over to the admin UI. Here, we can see some pretty interesting metadata about the session, the timestamps of when the session was created, bytes up, bytes down, the amount of connections established, as well as channels. The SSH spec defines global and channel message requests. Boundary is able to capture each of these messages, giving administrators the ability to understand what actions are being taken over a given session at a more granular level. Here, we can see the connections, as well as channels that have been established by John. And of course, we can play back the recording of John's session to see those actions he took on the remote machine. To the right, we can see bytes up and down for this specific channel, when this channel was created, as well as its duration. Additionally, we see some related information, including the target that we're actually looking at, the storage bucket where the recording is located, as well as the associated IDs. Recorded sessions are converted into the BSR, a specification we've created that defines a structure of files and a binary file format. It contains all of the data transmitted between a user and a target during a session and is available within your storage bucket. Additionally, these files are signed to ensure they're tamper-proof. We're extremely excited to announce the availability of Boundary Session Recording, and for these enhanced auditing abilities to land in Boundary 013. With that, I'll kick it back to you, Armon.
Awesome. Thank you so much, Adam. Super exciting to see how easy it is to enable this feature, and then how slick it is to be able to instantly come in and see those recordings and exactly what the users did as part of those sessions. Taking a step back, I just want to summarize some of the announcements for Boundary. Obviously, we introduced Boundary Enterprise today. That's now generally available, so this allows you to run the entire Boundary solution entirely in a self-managed mode alongside the HCP Boundary offering, which is delivered as a managed service. In addition, we're introducing session recording, also generally available, and that's available both within HCP Boundary as well as in self-managed Boundary Enterprise. And the first 50 sessions are free to try as part of HCP Boundary, so if you're excited to see what this feature, how it works and how it feels, log in and give it a try today. So now I want to switch gears and talk about the networking layer with Consul. When we talk about Consul, it's really at that identity-based approach to doing service networking. This is in contrast to Vault and Boundary, which are identity-based approaches to machine secrets with Vault or human-to-machine access with Boundary. With Consul, it's still in a machine-to-machine, but very much at that networking layer. So when we talk about the networking layer, there's 3 different sets of challenges we want to solve. The first is a discovery challenge. So if I have applications running across multiple clouds, multiple platforms, for example, one might be an on-prem VM-based workload talking to a cloud-based Kubernetes workload, how do those workloads discover one another and route traffic between them? That's really a discovery challenge. The next challenge is really a security one. How do I define the rules as to which applications can talk to which other applications in a multi-cloud, multi-platform way, where each of those environments has different sets of controls? With Consul, we can move to a service mesh approach where we define those rules and then enforce them in a common way across all these different environments. And then lastly is a network automation challenge, right? When we talk about load balancers, API gateways, firewalls, and other network middleware, we want those to be automatically updated anytime I deploy an application, scale it up and down, build a new service. And so Consul really sits at the center of all that, providing an automation tool for service networking. So today I'm excited to announce the availability of Consul 1.16, now in public beta. The GA of this release is coming in July, so just in a few short weeks, but I wanted to take a few moments to highlight some of the new capabilities that's coming as a part of this release. The first major enhancement, and this has been long requested, is the ability to do custom extensions for Envoy. So if you're using Consul to deploy a proper service mesh, where we're having all of our traffic go through a set of sidecars, Envoy tends to be one of the most popular choices for that. Envoy in this case runs as a sidecar alongside the application, so all traffic is going through it. This gives us the ability to do rich introspection on traffic for observability, allows us to impose things like TLS for security. But there's a lot of other use cases as well that get enabled when we open up the ability for extensions to Envoy. Two of the key ones that we've been commonly requested is one is OPA support, or Open Policy Agent. This allows us to bring custom logic and custom policy enforcement into the actual data path. And the second one is WebAssembly, or WASM extensions. This allows you to compile custom applications down into WebAssembly and then extend the data path by linking those WebAssembly applications into Envoy. So super excited about this feature, makes it much more flexible when you're using Envoy to be able to bring in custom enhancements and really fine-tune the mesh to work the way you want it to. The next major enhancement that's coming as part of Consul Enterprise is what we're calling sameness groups. And the use case really here is if I have applications that are deployed across multiple clouds, across multiple platforms, oftentimes they're in different data centers. They might be in different administrative partitions, which is a way of delegating subsets of Consul to application teams. But it might be logically the same application. So an example I might use is, let's say I have a billing API. That billing API might be deployed both in US East data center as well as in a European data center, and it's the same API service. Now, most of the time, if I have other services in my US data center, they want to talk to the US billing API. But suppose that that service is down for some reason. By defining a sameness group, we can basically say that, hey, this service is the same in both our EU region and our US region. And now that enables use cases like automatic failover for service discovery between these different regions. So if my US region loses the billing API, maybe I want to let traffic fail over to my European region so I have continuity of operations. So that's what this feature really enables, is this first to group logical services that are the same, even if they're deployed across different administrative partitions or different data centers entirely. So super excited about this feature, going to enable some very sophisticated failover and recovery use case scenarios. Now there's a bunch of other capabilities that are coming alongside these two with Consul 1.16, and we're not going to go into all these details, but some of the ones I want to highlight are things like the FIPS 142 certification. This now means Consul has achieved the Federal Information Protection Standard, which allows it to be used in a lot of regulated spaces that require a FIPS certification. In addition, we're bringing in things like JW auth support for service-to-service traffic, so this allows another mechanism of authenticating traffic between services as well. Then there's permissive TLS, and I think this really allows you to transition from a world where you don't have a service mesh into a service mesh by starting off allowing or running your TLS in a very permissive mode, where you don't have rules defined as to which services can talk to which other services. This allows you to transition to a mesh, discover basically what services are talking to each other, and then over time move away from a permissive model into a default deny model that's more restricted. Right? There's a lot of other good features that we'll highlight later on, but these are some of the key highlights. Next, I want to talk about what does it look like as we start scaling up Consul to multiple data centers and multiple clusters. Right? One of the challenges we've seen with operators at very, very large scale is that you have many environments of Consul. Again, multiple data centers, multiple platforms. And so when you start managing Consul across all that, there's additional challenges that come into scope, right? How do I know all these clusters are healthy? How do I perform actions that require multiple clusters? How do I orchestrate those global workflows that span all of this? And so I'm super excited to share some updates around the HCP Consul management plane. We introduced HCP Consul, the management plane, and the different capabilities late last year. And so today we have a set of updates I want to talk about relating to cluster peering, linking, and observability. So starting first with cluster peering, what we can now do is basically bring all of our various clusters into one view, right? These might be running across multiple clouds, they might be self-managed, but now this gives us a single portal where we can actually manage the peering relationships between them. Some of our clusters, maybe we don't want to have peered. For example, we keep staging in production as isolated clusters, where in production we might have, again, a US region and a Europe region, and those might be linked together as part of a single logical cluster. So some of those global workflows we can now automate through the management plane. The second piece, and I sort of alluded to this, is the notion of being able to link self-managed clusters into this environment. Previously, the management plane only supported the cloud-managed HCP console clusters, where now with linking capability, our self-managed clusters can also be configured and managed through the management plane. This provides a single management portal, whether now we are self-managing in a private data center, self-managing in a cloud environment, running at the edge, or in combination running these workloads with HCP console. So now we can link those self-managed clusters in and have a unified view. Lastly, there's a great set of updates around creating more observability. This is both for the clusters themselves and the workloads running within them. So making it much easier as we operate global scale infrastructure to really have a sense of what's going on, being able to troubleshoot and have more visibility into our environments. So to make all of this a little bit more real, I'm going to hand it over to Van, who's going to walk us through and run a demo of these new capabilities. Over to you.
Thanks for the intro, Arman. I'm Van from the Consul team. In this demo, we're going to enable this non-functioning HashiCorp application to show you how to enable hybrid connectivity of services spanning across self-managed and HashiCorp managed clusters across clouds. Our HashiCorp application is composed of microservices spread across self-managed cluster on premises and 2 HashiCorp managed clusters in AWS and Azure, both of which are already peered together. For HashiCorp to function properly, the microservices must be able to connect. To enable this, we will first link the self-managed cluster to HCP, followed by peering it with the AWS cluster. Once complete, we will show the cluster's operational insights in the observability dashboard. We're going to start with linking our existing self-managed cluster running on Kubernetes. In our HCP management plane, we already have 2 HashiCorp managed console clusters in the overview page, one running on AWS and one on Azure. And the service page is a central location that lists all services across all the clusters in HCP. You can see that we currently have 4 services between our 2 clusters. We will now go back to the overview and enter the deployment flow to link our existing self-managed cluster to HCP. We follow the steps provided to set secrets and edit our console values file, and then edit the self-managed console configuration. Once complete, the self-managed cluster will appear in HCP, and we will navigate back to the service window, and we can now observe the new services in the service catalog. Next, we're going to connect our newly linked self-managed cluster on-prem to our HashiCorp managed cluster in AWS. Navigating to the cluster peering page, we can see our existing peering connection between our AWS and Azure cluster. We will now initiate the peering connection between the AWS cluster and the self-managed cluster. We select the 2 clusters we want to peer with the corresponding admin partitions that the services are running on. The status will change to active once it's successfully peered. After exporting the services and setting service intentions, the AWS cluster now shows the imported services from the self-managed cluster. The services are now connected across clusters, and our HashiCorp application is also functioning properly. The last thing we want to do is get some insights and metrics to our console cluster. Heading back to the cluster list, we can then navigate to the observability page for self-managed cluster. Here we can view the health of our cluster servers over time, including visualization on the lead server heartbeat, write load and latency, and server host resource utilization. Envoy telemetry data can also be enabled with additional configurations using code snippets and instructions provided. Once configured, our console deployment will then be updated to show Envoy request rates, connection rates, server rate counts, and connection status. All right, so this concludes our demo where we showcased our new features and provided an example of how you can use HCP to deploy, connect, and visualize metrics at scale, all from a single unified management plane. Back to you, Arman.
Awesome. Thanks so much, Van. Super exciting to see all these new capabilities. Really excited to be able to see now that combination of self-managed and HCP console delivered, all being viewed and managed through a single portal. I think that hybrid capability is our view, really where most customers will end up. So taking a step back, I want to do a quick recap with Consul. Today we announced the availability of Consul 1.16, now in public beta, going GA in a few weeks, so please give us any feedback on that, as well as the HCP console management plane improvements that we just saw Van walk through. So excited for those as well. So lastly, I want to spend some time talking about Terraform and the infrastructure as code layer. I think most people are probably familiar with Terraform and infrastructure as code, but for us, when we really think about the use cases, obviously Terraform started with cloud and managing sort of infrastructure as service there, but I think it's grown steadily to a very broad range of use cases. Obviously its home is cloud, but now oftentimes used in networking automation, used in private data center environments, and used all the way up at SaaS layers. Because our view is, at the end of the day, what Terraform is giving us is a life cycle management tool for creating resources, managing and updating how they're configured, and ultimately cleaning them up when they're no longer needed. And that applies just as much at the underlying hardware layer, at the infrastructure as code, and the IaaS layers, all the way up to platforms as service and software as service. So we think it has a very broad range of applicability. Now jumping into some of the updates, right? As we've been talking about, security clearly very top of mind. And so when we think about the way Terraform traditionally interacts with various providers, whether it's Amazon, whether it's cloud services, etc., it needs to have API keys that allow it to interface with those services to do its orchestration. Oftentimes, those are provided as static values, right? So we might have a static API key that might be stored in a Terraform cloud variable, for example. And so every time we do a run, we're using that static API token to talk to the cloud service. Obviously, this introduces its own challenges and risks. Those credentials can get stale, they might potentially get exposed. And so ideally, we want to embrace the ability to use things like Vault to do dynamic credentials. So earlier this year, we introduced the ability to have Terraform workloads have an OIDC dynamic identity. That identity is then used to authenticate against Vault, and then we can use things like Vault's dynamic secrets to get a credential specifically for each time Terraform runs. So that gives us a dynamic temporary credential that Terraform can use to orchestrate within its run, and then that credential gets automatically cleaned up by Vault. So this allows us to move to a much more centrally managed model where all of our credentials can live within Vault, but it also lets us move away from those static credentials into a set of dynamic credentials. Now, when we talk about infrastructure at large scale, it's obviously not enough just to provision it day one. There's a whole life cycle that comes day 2 and beyond, and that has a bunch of questions associated with it, right? We start to wonder, where do we have modules being used that are maybe out of date? Where do we have providers being used that are out of date? Where's their infrastructure where it's drifted away from our intended configuration? So all of these really become challenges in a day 2, day 3 environment after we have long-running infrastructure. So today I'm super excited to announce the availability of Terraform Workspace Visibility. What this feature brings is the ability to help answer some of those questions and make it a lot more obvious when we're operating infrastructure at scale where we have things that are out of date or where we have things that have drifted so we can go in and remediate those issues. To show us a little bit more and make this real, I want to hand it over to Sarah, who's going to do a walkthrough of Workspace Visibility.
Thanks for the intro, Armand. Hi, my name is Sarah, and I'm a product manager on the Terraform team. Before I dive into Workspace Visibility, I'm going to start out by creating a workspace, and then I'll switch over to viewing that data from the new Workspace Visibility Explorer page. Armand touched on how the Vault-backed dynamic credentials capability eliminates security risks associated with static credentials by removing them from the workflow entirely. So I'm going to provision this infrastructure without using any static credentials. Let's start out by taking a look at a variable set I've configured for some AWS credentials. I've applied it to a couple of projects for the front-end dev teams who need access to these credentials. I've already configured an HCP Vault cluster and prepared it with an OIDC trust relationship using dynamic provider credentials. In this variable set, the TFC Vault address, namespace, provider auth, and run role environment variables tell Terraform Cloud how to communicate with my HCP Vault cluster. The remainder of these environment variables tell Terraform Cloud how to communicate with the Vault-backed AWS Dynamic Secrets Engine. These variables also configure which Vault and AWS roles are used during plan and apply phases. Notice that none of these variables contain any sensitive data like an access key. Now let's see how this enables a self-service workflow by provisioning a no-code module from the registry. A member of the front-end dev team can simply pick the module they want from the registry, hit the Provision Workspace button, fill in some input values, name the workspace, and assign it to one of those front-end projects, and get their infrastructure without ever handling provider credentials. Now that we've enabled self-service and have securely provisioned infrastructure, let's take a look at how the new Workspace Visibility feature provides a single pane of glass for your Terraform workspace data across your entire organization. I'm going to walk through the new Explore section of Terraform Cloud. In this initial launch, we're bringing visibility into your Terraform environment, including module, provider, workspace, and Terraform version information. Let's take a look at some of the details of that HashiDays demo website workspace that I just created. From the Workspace Explorer, I can see information about all the workspaces across my environment, including project name, ID of the latest run, module and provider counts, as well as a full list of modules and providers in each workspace. From the Modules Explorer, I can see a breakdown of similar information, but this time by modules. From this view, it's easy to identify all workspaces using a certain version of a particular module. From the Providers Explorer, I can see similar information, but for providers. And using this information, platform teams can effortlessly determine which workspaces require module or provider upgrades to ensure the security and consistency of their environments. From the Terraform Version Explorer view, it's easy to figure out which workspace is on an old version of Terraform so platform teams can notify those workspace owners to upgrade. We've also created a view for workspace health. Results of drift detection and continuous validation health assessments are collected in one place, providing a holistic view of the entire cloud estate. All right, back to you, Arman.
Thanks so much, Sarah. I'm super excited about this feature. This has been a very common request when we talk to people now operating mature at-scale estates, really trying to understand how to get their hands around these types of challenges in a day two environment. Next, I want to talk about a different set of challenges we see, right? Which is oftentimes what you see is, an accumulation of resources that may no longer actually be relevant, may not actually get used. Particularly, we see this very often in development and testing environments. For some large cloud customers, as much as 50% of their total cloud resources might be used in development and testing environments, and oftentimes a lot of that is wasted, right? It's resources that are long running that shouldn't be, things that are idle, things that haven't been deployed in a long time. And so how do we really look at those things both from a security respect, which is great, some of these things represent risk to us, but also from a cost perspective, which is a lot of these are opportunities to optimize and reduce our cost. So really excited to introduce the availability soon of ephemeral workspaces for Terraform Cloud. What this brings is the ability to do a few different things, right? One is to basically define a maximum time to live for a Terraform workspace. So whether that's a developer environment, we might say, great, I'm provisioning a dev environment, it should only live for 7 days. If I'm not using it, it should get cleaned up. Or if I'm provisioning as part of a CI/CD test, maybe I want this environment to only live for 24 hours. I bring it up, run some tests in it, and then it should get automatically cleaned up at the end of that testing period. So I can now define a TTL for a workspace, and this will have an as-code workflow, so I can define those TTLs within the Terraform configuration. That then allows Terraform Cloud to automate the destruction and the automatic cleanup of that, as well as to provide notifications. So for example, if I'm actively using it as a developer, maybe I want to extend that TTL because I'm still using it, versus if it's a CI/CD environment and I don't care about it, it can be automatically cleaned up entirely. So I'm super excited about this feature. You're going to hear more about this shortly from us. Lastly, I want to talk about how do we bring all of the various resources that we have under Terraform's management, right? Terraform has supported a legacy import mechanism for a very long time. This allows us to define and create a codified definition of a resource, for example, let's say a VM, and then be able to use the Terraform import command to import an existing VM and map it to that configuration. This workflow worked, but obviously had some challenges, right? The biggest being it required us to actually write the configuration of those resources and to get that configuration perfectly right. If we didn't get the configuration right, then once Terraform imported the resource, it would begin reconfiguring it to match our specification as opposed to just importing it as is. So to help solve some of these challenges, I'm super excited to announce the availability of configuration-driven import. This is going to be a part of Terraform 1.5, which was just released. And what this really enables Terraform to do is actually help automate that process of not only importing existing resources, but writing the configuration for you and having a workflow that makes it obvious you haven't made any mistakes or that you'll have any unexpected behavior. So to really showcase this, I'm excited to hand it back over to Sarah, who's going to walk us through this feature.
All right, I'm back for one more thing. Terraform has had an import CLI command for a long time, but it had a few challenges. Resources had to be imported one at a time, and the process of building out the matching resource blocks was very manual. The import command also immediately modified the state file, which could lead to accidental resource changes or even deletion if another team member was making changes at the same time. Let's take a look at how the new config-driven import feature improves this workflow by introducing a new import block that allows you to declare in configuration which resources to import. I'm going to start out with an almost empty Terraform configuration, just the provider config and no resource blocks. I also have an import.tf file with our new import blocks. Each block is going to take in the ID of the resource from the provider, as well as the Terraform resource address where it'll be imported. As you can see, I can do this for many resources at once. Here I'm importing 11. We'll kick off the import process by running a plan, using the new command line option to generate configuration for the resources we'll import. Terraform will read in each resource and generate a plan, which now includes the resources to be imported. Terraform has also let us know that it's generated configuration and written it to a generated.tf file. Opening that generated.tf file, we can see the resource block for each of those 11 resources has been generated automatically, along with all of the attribute values for each. Config-driven import has also been integrated with Terraform Cloud. It provides a more secure workflow because developers working on import operations no longer need direct access to state, and they don't need to have cloud credentials in their laptop. In addition to the CLI workflow, which I just showed, config-driven import is also supported for UI and VCS workspaces, which wasn't possible before. In the plan and apply run results in Terraform Cloud, you'll now see details of all the resources to be imported. Terraform Cloud also provides a view of generated code, which you can download and review before committing it to your Git repo. Now let's actually run and apply and import those resources to state. Thanks to the generated configs, this is a clean import with no unexpected changes to the resources. We can see the apply has completed with 11 resources imported and no unexpected added, changed, or destroyed resources. We can also run a Terraform state list command to verify that we have 11 resources in state. Back to you, Arman.
Thanks so much, Sarah. I'm super excited about this feature. This has been long requested to make it easier for people to auto-generate Terraform config based on existing resource definitions and make that import smoother. And I think this is a really slick workflow that makes it a lot easier to get going with import. Taking a step back, we announced a bunch of updates with Terraform. The first is workspace visibility, really looking at how do you make it easier to operate an at-scale infrastructure as code estate, day 2, day 3, and beyond. Configuration-driven import, which makes it easier to bring additional resources in under management with Terraform, as well as ephemeral workspaces, which make it easier to clean up unused resources and better manage our cloud cost. Now, taking a step back to all of the announcements, we covered 4 different product areas today: Vault, Boundary, Consul, and Terraform. Lots of great updates about those. You're going to hear more at other sessions and more from us throughout the year. But obviously, there's a broader portfolio of HashiCorp products as well. Unfortunately, we didn't have time today to talk about everything, but you'll continue to hear more updates from us, and looking forward to sharing a lot more updates this fall at HashiConf as well. So with that, I'm excited to hand it back over to our MCs. We have a great set of programming for you. I hope you enjoy the rest of the conference. Thank you.